Okay, so before I get started here, just a little show of hands. Who in this conference has already attended a TUF or Docker talk? Okay, great. I'm glad I don't see all of your hands. So, I'm Justin Cormack. No, I'm not. Okay, so just curious. Justin Cormack, apparently something happened at Docker, and Justin Cormack was right there. He saw the signal, and he had to run off. So I'm going to be doing my Justin Cormack impression. So to do that, I'm going to put on my DockerCon speaker, DockerCon 19 speaker hoodie to try to get me into the mood here. And I apologize a little bit for this, for those few of you who have been to a previous talk, because since I am Justin Kapos, professor at NYU, creator of the TUF project, I'm going to be giving this talk along with a PhD student of mine, Santiago Torres, who's right there, who's also at NYU. We're going to be focusing a bit more on TUF, although we will talk a lot about Notary at the end, and Santiago is going to do a great demo for us. So let me go ahead and get us started. So what TUF and Notary and other, the goal of them, the thing that they try to protect against, is they try to protect against a very specific attack vector. It's an attack vector that is used by some of the best hackers around the world. It bypasses any scanning and security systems that you have in place. So if you have a firewall or an IDS or other things like that, it's ineffective. It's on basically every device that you can imagine, every type of thing you can think about, whether it's a car, a refrigerator, an Xbox, whatever else. This attack vector is there. And it's also been used to just amazingly damaging effect by the best hackers in the world. When nation-state actors want to go and hack into things, they use this vector over and over and over again. And also, it's something that has hit many, many, many victims. So, if you look at this, this is a list of a lot of organizations that have excellent, security organizations and have spent a lot of time and money thinking about these types of problems. And if we wanted to, we could put 10 times as many logos on this slide and just overwhelm you with cases of this. And this vector and this thing that's being attacked is, attackers are able to go and compromise systems through the software update infrastructure. They'll break into something like a repository. They'll break into something like Docker Hub, for instance. And if it's not protected appropriately, then you could have a problem where attackers could go and harm a whole bunch of users. So one thing that people sometimes ask when I start to talk about, hey, we want to protect software updates and distribution of software, to say it's easy. You just use crypto, right? Like just like, hey, I have a bike, I just put a lock on it. Like, how hard can this possibly be? I've now protected my bike, right? But how you apply that crypto and what you do really matters. And so let's look at why a simple application of crypto is the reason why a lot of the companies on the slide before this ended up on that slide. Why their users, why they had problems, why they got hacked. So let's just say that you go, you have a setup where your server has X509 certificate, and this is trusted by your clients. So your clients want to go and update, and your server has the little silver star here saying it is the trusted party. So your clients will go and then try to retrieve content. Well, all that X509 cert and the private key and so on is telling you is telling you you are talking to the server. It's not telling you that what the server is giving you is a trustworthy, valid thing. It just authenticates who you're communicating with. So if the server gets hacked, then any of the clients can be given anything by that server. And of course, because you're running something like a web server with a full OS stack and a bunch of other stuff on there, it's complicated, and hacks happen time and time and time and time again. All right, so the other approach that got the other half of the companies on that slide is to do something where you have a separate signing key. So this is something like Maybe you use like an RSA key or a GPG key or something like that, where now you go and you have a bunch of developers, and the developers, one way of setting this up is the developers are all sort of trusted. Like you can imagine something like a key ring for something like Debian, where you've got hundreds of developers that have their keys listed, and then any one of the developers gets hacked. Maybe that's the developer that all they do is update the Polish language translation for a certain piece of documentation, but their key's on the key ring because they need to do that. Then they can go and push updates to the kernel or whatever other packages they want, and boom, you have a big problem. The other way that organizations do this using something like RSA or GPG, or even something like an HSM, is they go and they have a system in their infrastructure like a build server or something else. And that build server has a key on it. And then, of course, what happens and has happened with a lot of companies like Red Hat and others is that someone goes then and breaks into that build system, and then boom, they do it. So in all these cases, you sort of have this problem where if you apply your crypto in not quite the right way, you end up getting your name on my slide of shame in the beginning. All right, so I think I've convinced you that it's not easy to do this. Now let's talk about, is it possible? Like, is there a solution that you could have that would actually go and provide you with meaningful defense against an attacker that's able to do things like compromise servers, compromise keys, where you might actually make a mistake. I don't know if anyone has ever been in an organization that's ever made an error of any sort. Yes, thank you for all the laughter from the audience. I appreciate that. Yes, so everyone makes mistakes. So, and if you're going to possibly make a mistake, then you need something that allows you to make mistakes and not have that be an immense security problem for everyone in your organization. All right? And that's really what TUF is all about. The main goal of TUF is compromise resilience. The idea here is that even if you have a key lost, someone accidentally goes and publishes a private key into GitHub, or a developer, one of your DevOps people, starts to go a little, crazy and has to leave the company, but while that transition's happening, maybe they try to cause a little bit of panic and problems on their way out. TUF is designed to try to help so that you don't have single points of failure or single problems, and also, when that happens, to recover gracefully, so that the damage that's caused by an attacker is minimized and you can get back to a secure state even when that occurs. So if in the example here with TUF, you would have a TUF repository. The attacker might be able to go and break into something like Docker Hub or your repo, and yet your users are not at any substantial risk. And we'll talk a little bit about how that works. But first, I want to talk about one of the other goals of TUF, which is to support, not to judge. So we know your infrastructure looks like this, or at least parts of it do. TUF is not something where, it's not like PCI compliance, where it's a checklist of things you have to do to meet some standard. TUF is a flexible system for letting you go and have a sane setup that basically matches your workflow and give you protection and security around that, okay? So you can keep your rat's nest and have it be better protected with something like TUF, and also do so in a way that doesn't cause you to, to end up having a bunch of operational additional work or other things like that as you're going through the process of packaging your software. So TUF does this with 4 different properties in the design of TUF that I'll talk very quickly about just to give you a flavor, and then we'll get to the exciting stuff of, hey, let's look at how Notary implements this and some of the things about what they're doing. So one notion that TUF has is it has this notion of responsibility separation. So in TUF, there are multiple different keys, and there are parties that have those keys, but those parties will have different roles. So for instance, someone who's a developer would be trusted to do things like sign a package that they're responsible for producing, not other packages, but hey, if I'm a developer for the Intoto project, then I can sign and say this is a valid release for Intoto, but that doesn't mean that I can go and sign and say this is a valid Spiffy, Spiffy Spire release or something like that, even though they might be on the same repository. And also, there are different roles that do different things. For instance, the repository is responsible for knowing things like, has there been a new update? But it doesn't know, it's not trusted to tell you this is a valid update. Because there's a distinction between the two. The developer has to tell you, this is the hash of the right, this is a signed thing attesting this is the right update. The repository just says, there is a new update, for instance. Okay, and I kind of already talked through that. So another design principle in TUF is operationally, it's intended to be something that you can meaningfully apply inside your organization and get real security. Of course, you could say, we can make a perfectly secure system where every time anything happens, you have to get a DNA sample from every person in the company to validate this, and they have to put their firstborn child in escrow and da-da-da, all this stuff. But it's just not realistic. Like, no one would ever use a system like that. So TUF is designed so that you can go and for the things that would be very sensitive, like for instance, developer signing a package, you can have something like a YubiKey that you have, that you're able to go and do this, which isn't a big burden, or you can use your GPG keys that maybe you already use to sign Git commits or whatever else like that. So it's basically just in your workflow, you do the same normal things like you normally are doing, and in some cases for things where you need to have a way to recover, for rare events, you might have a couple of keys that you put across different sites, YubiKeys in desk drawers or things like that. But for keys that need to be online on something like the repository, the impact of that key being compromised is extremely low. So if it has to be online, which means it has a high probability of an attacker, especially someone like a nation-state actor, being able to get at it, then the impact of that compromise is something very low. Like for instance, I might be able to say that, hey, there hasn't actually been an update to this specific piece of software for a week before you realize that something fishy has happened. And that's sort of not anywhere near as bad of a problem as me being able to tell you, hey, no, you should install this update instead. It has this special crypto miner feature now in it. Okay, right, so if the impact role is high impact, then we make it so that from a usability standpoint, it's easy to do things like keep keys offline and not have that be a burdensome thing for your operators. If the keys have to be online, then there's a very small impact if a compromise occurs. Another thing that TUF does is something that, if you've heard the old thing about the nuclear submarines, you can have threshold signatures on anything you do inside of TUF. So you can say, for instance, 2 of the 5 Intoto developers need to go and sign a new release of Intoto before it's trusted. Or, for our root keys, you have to have 3 of the 6 root keys, be pulled from sites around the world and do things. And that way, if you do have an incident where you have like Alice and Bob here that have their keys, and Alice's key is compromised or leaked or whatever else, or Alice goes crazy, then there's no risk to clients in that case, because you can securely revoke. And that brings us to the last point here, which TUF was designed from day one with the very first, the primary goal is compromise resilience, is to protect and recover securely when something goes wrong. So that means revocation was a primary initial overriding goal, doing revocation right. And anybody here who has dealt with GPG, PGP revocation, or X509 revocation in that whole domain, you know that that was not a primary first order thing that they were thinking about when they built those systems. It's really, really painful and does not work well, okay? In TUF, it's amazingly seamless, works well, and you can rotate keys and do all kinds of other stuff like that. That's very hard to do in other contexts. And there's even multiple ways where you can do this, where you can both have keys that you explicitly revoke. It's a very simple, your operation that you do to delegate is you say, I want to go and I want to trust Marina to do this action for me. And then all I have to do to revoke my trust in Marina is say, generate the same file and just remove the line that said I trust Marina. I want to delegate to Marina. I remove that, and now once I push that up to the repository, then trust in her has been revoked. Oh, sorry, and you also have revocation that works based on time and delay. I'm going to skip through this to get to some of the Notary stuff, but if you want to learn more about the roles in TUF and how this all works together, then I'm happy to answer this later with questions, but I want to make sure that we get you to some of those aspects. TUF itself is standardized and used in a lot of different domains. The Python community did some of the earliest standardization of TUF. There's a few different implementations by different groups that are used. The one we're going to focus on in this talk is Notary and all the other aspects of it, although the Python reference implementation is used in production by Datadog and a few other organizations. Google, Amazon, and others have their own implementations of TUF that are used. There's also an automotive version of TUF called Optane that is part of automotive-grade Linux and is has multiple major OEMs in the US, in Japan, and in Europe that have adopted it. And so within 3 years or so, it's projected that 1/3 of new cars on US roads will include Optane as part of it. Optane has also been standardized by IEEE ISTO, and is a Linux Foundation JDF project. So let me talk really quickly about the impact of a compromise in TUF, just to make this kind of clear. So if someone goes and breaks into your repository in TUF, I'm going to focus, the second column here just shows, are they able to install malicious updates? Because this is really the most important thing I think you care about. And then the last column is, can they recover securely? So if someone breaks into your repository, they can't install malicious updates, and you can securely recover from this instance. If someone steals a developer key but doesn't have a means to cause the repository to accept the developer commits or things like that, then there also is no impact. If someone is able to go and steal a developer key and able to either break into the repository or get into the repository with the developer's credentials, then they can do damage, but only for projects that that developer was trusted to do. And that also assumes if you have a threshold, that you got a threshold of those developers for the project to be compromised. And even in that case, you can still securely recover in the system. If someone steals less than a threshold of a certain type of key called root keys that operationally you use once every 6 months or so, that most organizations, they go and they just have a couple of YubiKeys in desk drawers around the world or whatever, then that also isn't a problem. If they do some Mission Impossible Ocean's 11 style heist and they manage to get a threshold of these all at once without anybody noticing, then all of a sudden you start to have a problem, okay? But it's a pretty high bar. A last thing I'd like to talk briefly about here is TUF itself is a specification. Notary is one implementation of it. And as part of being a specification, we, of course, also have changes to the specification that we take in from different communities. So we've gone and integrated a bunch of changes over time. We have even some changes going on now. If you're interested in participating in this and you have use cases that you figure out that we don't handle, then that's something that's how you end up being an author for some of the taps and things like that on this list. And I already talked through that. So now I'm going to go and I'm going to hand over to Santiago that's going to take us the rest of the way and show us a bit about Notary and a cool demo.
Am I back up? Can you guys hear me? Yeah. OK, so as Justin was mentioning, Notary is an implementation of TUF that's optimized to work better on cloud-native workflows. So it was originally developed by Docker. All of the companies that you saw on the right-hand side of the graph that Justin was showing. And it was in conjunction with a container registry because, well, it was geared towards cloud-native applications. To give a little bit of an overview, the way that Notary works, it separates things into two things. It separates TUF workflows into two things. One of them is you have the metadata server where you store all of the information about the container images, anything else that you would like to secure with Notary. And it also has a Notary signer, which is going to offload many of the operational things of keeping snapshot and timeliness keys that sometimes don't make much sense in systems at scale that are swapping in and out components very fast. So in order to deploy a Notary, your own Notary server, you generally have to have 2 database servers, or 1 in conjunction, depending on how you consider your threat model. And then you have to have 1 or many replicas of a Notary server and 1 or many replicas of a Notary signer. This will make a little bit more sense later. This is a repeated slide. I think this is. Now, there's also Notary right now is ongoing changes. There's going to be a Notary version 2 that will improve usability quite a lot. It will also help with the key management conundrum. So if you're interested, you should join Notary v2. I'll talk about it later on the CNCF Slack channel. And that will also come into play with Docker Content Trust and OCI 2v2, which is like an open standard for container registries. So I'm going to jump into a quick demo just because I want people here to be familiar with the tool a little bit. I also want to show how you can easily start playing with it. I know that developing for Notary, if that's something that you would like to do, and I highly recommend it, may not be very obvious from the get-go. It's hard to get started. So I have this here. Oh, damn it. We're back there. I'm sorry?
He's trying to get it, I think, so he can see what he's typing.
Oh. Yeah, so I have 2 terminals. Yeah, OK. So I am in the Notary repository. I pretty much just cloned it. And I pre-built everything because I don't trust the Wi-Fi in this. But the command that I want you guys to pretty much take a picture at is you can run this. And I'm going to run it now. And it will spin up a MySQL server that contains all the databases. It will spin up a signer and a server. And then it will drop you into a Notary client. So say that we are making some changes to the Notary client because we're trying to contribute to open source. We just type make client, and it's going to build Notary for us. And if my computer is fast enough, we'll beat the timer. We're good. Now I'm going to create a Notary repository where I'm going to sign and save some information that we will later verify. So I will go to bin, Notary, CMD, Notary, config.json. OK, I'm just basically telling it to use the config that comes built in. If you want to change it, you can take that file as a template and start saying and tell it. So then I'm going to tell it to init a registry, a repository, and then I will tell it what's the name of the namespace that it works with. So I do this, it will ask me for a root key. So So I wrote the password for the root key. This created a root key, which is the one that Justin was talking about for recovery. You usually want to take that root key, put it in a safe place, probably in an actual safe, maybe distributed in different geographic locations in case there's any disasters. And then I will have a targets key. Which the targets key is the one that I'm going to use to sign for files or for container images or anything like that. And finally, I'll have a snapshot key, which is the one that lets me know that what's the state of the repository. This is part of the role separation that Justin was talking about. So I did it. I created a registry. I have all the keys. If this wasn't a demo, I would take those keys and put it in different places and in a way that it makes sense for my operations team or my individual needs. And now that I did this, I will add a file. I will just add a file from the repository. This could be a container manifest. If you're using Docker Content Trust, there's like a seamless way to pretty much quickly pass a container manifest so you can sign that. Oh, and I probably need to tell it where to add it. So I added the file, and now I'm going to update. I'm going to publish my registry with the file that I just added. So I did it, and I think I know what happened. This is I have an old copy of the repository, so we can actually check what's in there, and. Yeah, okay. So I did the demo before. There's already a repository published there. I will try to.
I did mention he asked us to fill in at the last minute, right?
This is how you know it's live. But basically, what should happen now is I publish everything. It gets pushed into the trust Notary repository, and then I can fetch it and run validate over it. So and I also think I made a typo somewhere. Okay, I'm going to go back. I'm going to bail. It's sometimes you need to know when you have to give up. So. Back to this, GitHub. We have a GitHub organization that hosts both of the implementations, and there's also channels on the Cloud Native Slack if you want to participate and contribute. And you can also reach out to Justin Cormack or Justin Capos for questions.
Awesome. Thank you.
Thank you.
So I think we have some time for questions.
Is it on? Okay. Here.
So, whoa, that's loud. So you were uploading a file. So how does Notary actually work in this case? Are you uploading the file that you're signing and then it's signing it and publishing it to a registry, or is it a registry itself, or
so it pretty much points to a registry. So it is signing something that's living on a registry.
Okay.
Whether it's a container manifest or a blob, it really doesn't care.
Okay.
But if you want to, I mean, you could, for example, use Docker Content Trust and just enable trust to sign for container manifests when you push, and they will be pushed into a Notary server. You could also do the CLI if you want to do like more granular control over what you're pushing to the registry.
So if I was going to implement Notary in my organization, I would link it to like Harbor or something like that? How?
So for example, say that you want to pretty much just sign your images, push them to Docker Hub, and verify before they are admitted into. So there is a part of the Docker command line tool that's called Docker Trust. And you can do Docker Trust, I think it's generate, and you generate these keys that I showed you. Then you can do Docker push, and I think you pass minus sign, or you can enable, there's an environment variable called Docker Content Trust. You can just set that to 1, and it will automatically push the signature information into either the Docker-hosted Notary, or into the one that you want to push to, which you will have to fiddle a little bit with the configuration. If you want to host your own like trusted collections, then you can put your own Notary server in your organization and then point your Docker clients there.
Okay.
Now, on the admission side, when you want to verify, I recommend using an admission controller called Portieres, which you basically just fiddle a little bit with the configuration and tell it, well, whenever you push, look at this trust registry and verify that any image that's being passed through has a signature by a trusted party.
Okay, so Notary is kind of like a signature registry?
Pretty much. You can think of it like that. It's a signature registry that allows you to have all of these like pretty cool security properties.
Okay.
Because you can have things like, well, if the people that are building base images, for example, the official images are being signed by Docker. And you can have things like, well, but if I have my own like application, then it needs to be signed by somebody who I trust. So you have that namespace and that key, well, in a sensible way architectured, so you only trust the people that are pushing there.
I don't know all of the specifics, but I do know that Harbor does do content signing, and it does use Notary to do it. So if you did want to deploy your own registry, you could go that route.
We have a question up front.
What if I'm actually less worried about, I mean, I'm gonna key my images forms that should go to the field and not the ones that are built by the developer team, so I don't really need my repository to not admit things that aren't signed, because many of my images won't be. What I want to make sure is that Docker doesn't run unsigned images in the field, but of course runs unsigned images in my building. How does this all work together to achieve that result?
So let me see if I understood correctly. You are wondering whether there's a way to stop an image from running rather than stopping an image from being pulled if it's unsigned, or?
I want to make sure that the image, my registry will contain a mixture of signed and unsigned images, but only the signed ones get shipped to my customers. And I want to make sure that the customers don't accidentally load an unsigned image.
Oh, that's actually easy.
I like easy.
So if you enable Docker Content Trust, whenever you Docker pull, if it's not signed, it's going to bail. As far as I'm aware, last time I checked. Now, that would be on the client side. So it is pushing.
The client has to check, so yeah.
No, I understand. We can explain to our customers what the benefit is of implementing this. We just have to be able to tell them what to do.
Right. Well, the benefit is, first of all, that there's a signed policy in the sense that you can say, well, I am doing many images, but the ones that are like correctly made or the ones that are like for you, they have a higher like trust assurance, and you should enable this just so nothing wrong happens.
Yeah, I think you've given me the thread to pull to do the research to figure out how to make that all work.
Okay, any other questions? We have like 1 or 2 more minutes.
So I think we're done.
All right, well, thank you all.